Hello dear students, today we are going to the lecture number 1, it's Introduction to Colloid Chemistry. So in this subject we are going to talk about some different types of colloidal systems, how they are working with them, their properties, and some other substance. So here you can see the contents of today's lecture. We are going to talk about the colloidal state, its classification, preparation, surfactant, and micellization process. Also, we will talk about the properties of colloid dispersion. The information will be given, the general one, and after in each lectures I will give you the total information of each of the colloidal dispersion systems. So colligative properties, kinetic properties, optical property, and so on. Also, we are going to talk about the colloidal stability and its applications, the types of them, gas, liquid, foam, and etc. Please, next slide. So, in this slide, I will give you the references. So, students, you can also search the references from the websites, or you can see from this, and I will send you via email the e-books or the journals and other sites which you needed from the teaching and learning the colloidal chemistry. Next please. So I show you the general evaluation process of this subject. And so for the assignment it's 20 points, for the report presentation 30, and the final exam will take the half of point of the total 100. Okay, next. The colloidal state definitions. Let's talk about the colloidal state. So when we are talking about the colloidal system, we see that it's something like suspension or some of the substance which have different types of the viscosity or the density and some else. So generally the colloidal state is particle with linear dimension between from 1 to 1000 nanometers or 10⁻⁷ to the 10⁻⁴ centimeters. And other definitions is particle weight, particle size, and etc. So next please. So here you can see the length scales from the CC bond, for example, from 0.1 nanometers, and the maximum one is the 100 nanometer. It's equal to the colloidal crystals. And other ones, radius of gyration, micelles, vesicles, emulsion droplets, and latex particles is equal for each of them regarding. So please next. In this slide you can see the homogeneous mixtures. It's another word, you can see the true compositions and properties of them. Their property will be like particle type, particle size, and Tyndall effect, each of them. So in most of the laboratory works we can work with the true solutions, with the colloidal states one, it's like suspensions, for example. And here you can see that in the true solution, for example, particle type will be work like ions, small molecules. In particle size number is 0.1 to 1 nanometers, and Tyndall effect is no. In suspension mixtures we have the large particles and from 100 nanometers and larger. So it can go like in the previous slides I showed that the maximum one will be to the 1000 nanometers. Please next slide. Colloidal systems has different type, as I said, for the dispersed medium and for the content medium. So here you can see gas, liquid, and solid. So all of us, we know that in our planet or in the world we have 3 of them, gas, liquid, and solid. So we don't have gas, yes, there is no like a substance like a dispersed medium. Gas, liquid, like a liquid aerosols, fog, mist, or in perfumery also girls and boys using some of the liquid aerosols. And the gas solid is solid aerosols, smoke, air particulates, and other. In the liquid gas we have foam, whipped cream. Whipped cream is mostly used in the bakery, in cake bakes. So in the liquid it's emulsions, milk, mayonnaise, hand cream, some of the cocktails and drinks. So solid, liquid, is salt, paint, pigmented ink, and blood. Yes, human blood also is a solid liquid colloidal systems. About this I will talk you further. The solid gas is solid foam, aerogel, styrofoam, pumice. And for the solid liquid is gel, gelatin, jelly, cheese, and opal. Cheese, like we have the two types. It's a liquid one, I mean the mixture, and the second one is hard, so solid one. So solid is solid salt, cranberry glass, ruby glass is also dispersed medium of colloidal systems. Please next. So in this slide I will show you colloidal dispersions, macromolecular colloids, and associated colloids, the different types of them. Colloidal dispersions is like aerosols, emulsions, salt, foam, and paste, like a teeth paste or another one. Also coffee have some foams on the upper tube on the bottom. So macromolecular colloids is silica gel, basalt, zeolite. Associated colloids is from the different types, for example from the foam or from the silica gel, they have their surfactants is surface active agents which is affecting to the micelle formation. It means that here we have from the head and here we have the tail, and they are making some formation of micelizations, and after we can find some critical concentration of the micelle. So please next. In this slide, critical micelle concentration determinations. For example, we have three different types of the colloidal systems, A, B, C. So each of them, for example, like working surfactant and surface tension. For example, we know each of them surface tension for the substance A, B, C, and here we have A is higher than B and C, and B and C is equal to each other. And now we can see that the critical micelle concentration will be at the point B, because from the starting with the B, it's taking their constantly norm of the surface tension. So, or another word, we can see the concentration for each percentage, for example, use of protective colloid or surfactant only here. For example, for the substance B and C, 70.6, and for the C, 69.3. Or we can find from the diagrams that quantity of surfactant added from the percentage or the current addition quantity to the viscosity of them from the 0 to 5 thousandths. So the measured temperature will be equal to 25 Celsius, and the control standard is from 900 plus minus 300. So here we have the concentration of our micelle determination. It's equal from this, from 70.6 and to the 69.3%. Please next. So here we have three main common surfactant classes. It's a cationic, anionic, and non-ionic. So for the cationic, you can see that the nitrogen has the plus ion. This is the cationic, and where the bromine is minus anionic. For the anionic one, the sodium dodesulfate, for example, the salt has the minus anionic ion, where the sodium is plus cationic. And non-ionic, there is polyethylene oxides. Polyethylene oxides because they have unlimited number of the polyethylenes. That's why they have non-ionic. So please. Also, for the colloidal systems, we have the state hydrophobic and hydrophilic. Hydrophobic is, like a definition says, that it's afraid of the water. That's why they're called hydrophobic, where all of the heads are spreading to the bottom. And hydrophilic, this one is where the substance or the mixture loves the water. That's why it's called hydrophilic. For example, here C12E6 adsorbed at the air-water interface in the presence of oil, for example, this one. So here you can see that this substance is hydrophilic. Okay, please. Or this example, for example, water in oil. here you can see that head, water in oil, water will be in the up of the mixture. That means that water is just the oil will be in the up and water will be in the down. So head will be affecting with the water and tail will be going to the out. This means that mid-cell formation will be from the contrast way. Tail is in and the head is out. Or oil in the water makes another ligand of the formation of surfactant. Oil, water and surfactant. So here you can see the detailed form of the big continuous micellar formation from head to tail or from head to tail. So please next. In this slide I showed you some examples, different examples of the surfactant products where the surfactants are the primary components. For example, when you're buying some mixture for the washing or dish washing, you can see that, for example, dish soaps. You can see and read the content of them, where the surfactants will be the primary components. So primary is written from the first line. Or here products where surfactant is a secondary component in the material or the production. So it's the sum of the vinyl glue or vinyl mat, GTX or another one. Please next. So also I said you that human blood is also colloid system. So we have myoglobin in our blood and hemoglobin. So depending on the hemoglobin, we can see that some amount of vitamins or minerals we are losing or we are overeat. And that's why the doctors are recommending us to eat or to give more of them. So nanogolf balls also affecting like a colloidal systems. It's just spreading from the microscope for the 100 and more size. And also we have the multiple colloids. It's oil, for example. Oil and oil products has different mixture. For example, in the oil we can't just take from the oil from the refinery one and just working it and use it for the driving the machine, yes? Because we have to take it, get it to the recycling for the first type and for the second one, third one, and after we are taking the products. Okay, please? Also here in this slide you can see the preparation of the colloidal systems. So we have two basic methods of forming colloid. First one is reduction of larger particles to colloidal size, condensation. And here the small particles, intercolloidal particles, will be in the different way. So the second one is spontaneous dispersion in the proper solvent. So it will be the metal evaporation in an electric car to form a metal vapor cools also. And another one is solid reduction in a colloid mill. So emulsion preparations by homogenization with the addition of emulsifying agent. For the homogenization, for example, we can see the liquid-liquid or the solid-solid one. So the second one is condensation of smaller particles to form a colloid, usually involves chemical reactions. Typical like displacement, hydrolysis or oxidation and reduction. So this process is using for the making colloidal gold, colloidal silver. Next. So some areas of science and technology in which particles of colloidal size range are regularly encountered. So we have different types of the chemistry, as you know, and in analytical chemistry we are using the absorption indicators, ion exchange or the chromatography, gas chromatography or liquid chromatography, and decolorization. In the physical chemistry we have superheating, supercooling or supersaturation and liquid crystals. And the last one is biochemistry and molecular biology. It's a process of electrophoresis, osmotic and Donan equilibrium, and proteins, acids, viruses, nucleic, hematology, and even our blood is participating in this process. Okay. Also here the different types of the manufacturing when we are using colloidal systems, suspensions, aerosols, gels or another ones. So it's used in chemical manufacturing, environmental science, material science, petroleum science, household and consumer products. So we can see mostly use it every day in a household and consumer products milk and dairy products. For example, waterproofing, cosmetics, yes, girls are mostly using, and encapsulated products. For example, in petroleum, it's oil retrieval, emulsification, soil porosity, and other. In the material science, it's powder metallurgy, ceramics, cement, fibers, and particles of all sorts. In environmental science, we can see the aerosols, fog and smoke, foams, cloud seeding, clean rooms, and another one. In the chemical manufacturing, we can see catalysis, soaps and detergent, paints, adhesives, ink, paper coating, and the different types of the lubricants. Okay, so we are going to the end of our lecture, and now I'm going to give you the assignment number 1. So first you have to search from journals or websites to find an example in any branch of science in which particles in the colloidal size range are encountered. The second type is a write-up in your own words, not to make a plagiarism as all of the students make it. Just write in your own words a concise paper in A4 paper, at least 1 page. So, and the deadline is September 21st this year. For this assignment, I will give you 10 points. So, thank you for your attention and good luck on your assignment.